So question 13, right? We already drew the picture last time, and then we just follow the step that we discussed before. First, we need to find the slope using calculus, right? So slope at any x, okay, by derivative. So you take the derivative, right? And based on the equation, we know this one needs to do implicit. So I think it was Jeffy, right? When you did the implicit, you forgot you need chain rule. So you can look at your homework, okay, make correction to that. Right, so this one, if you prime, I'll give you 2x plus 8y, but then because of chain rule, you need to times it by y prime. Okay, and then some of you just wrote down 8y prime. Then you forgot the main point for the whole implicit, right? Implicit means you have to treat y as a function. So if the y is inside the square, you got to apply the chain rule. So equals, the other side will be 0. So isolate the y prime, then that will be negative x over 4y. And we forgot one thing, right? We should begin by letting the tangent point to be AB, right? So therefore, the slope at AB will be negative A over 4B, right? Based on the formula that we found. Okay, so step 2 is also find the slope using rise over run, right? Rise over run between the point that they give you and the tangent point. So rise will be b minus 0. So everyone got this part correct, okay? And then a minus negative 10 will be a plus 10. So both of them are slope, okay? Both of them are slope for the tangent line. So they should equal each other, right? So next part, we need to solve the system. System means you get the two equations, right? So first equation is when you have b over a plus 10 equals to negative a over 4b, right? The two slopes equal each other. The other one is the tricky part, okay? I still remember it was Carrie told us to sub in, right? The point. And then, so if you sub in AB, right? Because AB is on the ellipse. So AB, you can put it inside the ellipse equation. To get a squared plus 4b squared equals 36. So that's our equation 1, equation 2. Then you are almost there, okay? Once you got the two equations, the rest of them is just try to solve for a and b, right? So for number 1, we can manipulate a little bit, right? So some of you did it differently, right? But if you try to cross multiply, right, simplify equation 1, you'll see there's a connection between 1 and 2. Then that will simplify your solving much easier, okay? So if I cross multiply number 1, get 4b squared equals to negative a squared minus 10a. And then move the a square over. And then you see that the left side just look the same as the second equation. So I can replace the left side with the 36. So you see it's much easier if you stop and look and move it around, right? Maybe there's a surprise, right? So get A is negative 3.6. And then once you get A, the rest will be easy, right? B, you just need to sub in into the equation, either one, right? So what did you get for value for B, Jesse?
Let me see again. B, I got B.
Yeah, B.
Oh, B, I got plus minus 12/5.
12/5, so like 2.8 then.
Yeah.
Yeah, okay. 12/5, yeah.
Wait, 2.4.
2.4, sorry, yeah.
Yeah.
2.4. Okay. Yeah, so pretty nice number, right? And once you get A and B, those represents the 2 points. One is on the top, right? Negative 3.6, positive 2.8, 2.4, and then the other one is the negative 2.4. And once you get the point, you can get the slope, and then you can get the equation, right? So I think the hardest part is try to set up the system, right? Once you get there, the rest is your grade 12, grade 11 algebra, right? Okay, so today the main thing is trigonometry. Okay, trigonometry has two parts. First, we need to talk about question about limits. Okay, some of them we mentioned in before. Okay, and then the second part is the derivative of trigonometry. Right. So, any question about homework other than that one? And I also noticed that sometimes I throw out some question that doesn't have answer key, then you start to show problem. So try not to just copy the answer key off, right? You got to do a little bit, right? Do something when you get stuck, and then check the answer key if you really need help, right? Otherwise, if we change the question a little bit, then you get stuck again, right? So answer key is there to help you, not to not for you to just depend on it. Right, so let's start from here, derivative of trig function. So first we need to talk about some limits. So the first one is saying that if we take the limit of sine theta over theta, so, and then we make the angle as close to 0 as possible, then those two will equal to each other. So that's why the divide will equal to 1. So the way to prove this, we're going to use area. Okay, so if you have different color of pen, it's gonna help here, because this picture is quite confusing, right? A lot of lines here. So here I would like you to focus on a couple pictures. Okay, the first one, I'm going to use the red. So it's the triangle OBA. Right? Triangle OBA. And then the next one is the sector. Right? Remember from grade 12, you learned about sector. So I'm going to use the green one to represent the sector area. Okay, so sector OBA. And then the last one, I'm going to use the blue to represent ODA. Okay, so we get 3 triangles. I hope it's not too confusing here. Okay, with color, it can help us. So these 3 are different sizes, right? So of course, apparently the smallest triangle is the red one, right? So we can draw it out. The red one will be smaller than the sector one, right? And then smaller than the last one, the blue one. Smaller. Okay. So the way I'm going to show this is using squeeze theorem. Okay. So if you look at the question, the first one that we want to show, if we just sub in 0, you get indeterminate, right? Sine of 0 is 0, right? And denominator of 0 is also 0. So you cannot find it by substitution. And then there's no factoring, right? We cannot simplify, cancel out, right? So the only way to go is to use squeeze theorem. And squeeze theorem, we need to find 3 things, right? To include, right? To make a sandwich, right? So this is the inequality we want to use. So for the first one, because this is a unit circle here, the 1 is from here to here. Okay, O to B. Okay, and then it makes the sector area, the radius 1. Right. So 1 will be here. Let's label that. This will be 1. This will be 1. And then for the blue triangle, the 1 is down here. Right. If you look at the picture. Any question about the setup so far? Can you raise your hand?
Why is the 1 on the bottom for the blue one?
Yeah, if you look at the picture, right? So the 1 is touching point B from O to B. Follow so far?
Yeah.
Yeah. So if you draw so this is the radius for the green sector. It's also the radius for the green sector.
Oh, okay. Yeah,
so it turns down, right? Makes a green curve, arc, right? And then it stops at point A.
yeah, okay, I see it.
Yeah, okay, very good. Any other question about the setup? All right, so let's begin then, okay? So the first triangle, what I'm going to do, we are trying to find the area of each triangle. Sorry, each shape, right? So first one, the area of course is the base times height divided by 2 is the triangle, right? The base is also 1, right? Because it's from the picture we said is here, O to A, that's also 1, right? So base times height. Height will be here. So how do we find the height? How do we find this height? Anyone? If we have the angle, we have the hypotenuse. How do we find the height?
A squared plus B squared equals C squared.
But you need to have a right triangle, right? Are you looking at the right triangle at the bottom?
Yeah. Can we use
Do you
sine
have
rule?
2 of the sides? You need to have 2 sides.
Oh, crap.
Right? Any other way?
Wait, so what do we have? We only have 1.
We have 1 there, right, on the hypotenuse, and we also have 1 for the whole thing, right? That's the base. And then we also have the angle data. So how can we get hypotenuse? Sorry, how can we get height? Using angle, how can we get it? Suppose you know the angle data.
Oh. Oh, wait, never mind.
Anyone? This is from grade 10, okay? Doable.
Are we using the special ratios?
Special ratio, well, this one is movable, so it's not special. The data can be any angle.
Could you use like
Cosine law?
cosine law or
Cosine
yeah,
law.
sine law?
Cosine law.
Isn't it sine law?
Sine law, you need to have a pair. If you remember, you must have a pair. So right now, the side right? Each side their opposite angle, it's unknown, right? Pair means you have a side and the opposite angle, right? You must be given that. Don't think too much, right? Just think about think about SOHCAHTOA.
Like, isn't it just opposite over hypotenuse?
Yeah, that's it. Okay, what's the opposite?
H,
And hypotenuse?
1. So it's
Yeah.
just H.
So h over 1, and which ratio is that?
Sine theta.
Sine theta, right? So height is just sine theta, that's all. Right? Base times height divided by 2. So that represents the area of the red triangle. Okay? Now let's move on to second picture. Second picture is the sector. Anybody remember the sector area formula?
Are you sure we learned that?
Yep, yeah, we did. Take out your grade 12 textbook. If you haven't recycled.
Oh, is it the LR thingy?
Yes.
Is it half LR?
I don't remember
LR,
what it is.
that's for yeah, half LR, right? Yeah, but then what's L? Do you remember?
The length, 1, of the
No.
radius, because it's a
Radius
unit
is the
circle.
R. Yeah. So what's L? Check the notes. Have something.
Wait, I have a question.
Yep.
Isn't there the other one where it's like half r squared theta or something?
Yes. Okay. So because
use
the
that one.
L is the arc length, but we are not given that, so we cannot use it. Okay. So we are gonna just use the second formula for area, theta r squared. Okay. So that's for the green area. Now last one, that's also a triangle, and it's a right triangle, right? So base times height. So this time the height is over there. So which ratio do we use to find the height?
Tangent.
Tangent now, right? So height is tangent this time. Okay, so this one will be base is 1 times height divided by 2. Any questions so far? Okay, so now we have a sandwich, right? And we are going to simplify this a little bit. They all have half, so we can multiply everything by 2 to get rid of the half, right? It's not needed here. And also for the middle one, the radius is 1, so we can simplify this into 1 square, right? We can plug it in. Theta times 1 square. So if we do that, the sandwich now looks like sine, and then theta, and then tangent. This is a very important sandwich. Okay, depending on what question they give you, right? You can base on this and then start to move them around. Okay, so let's box it first. Okay, a very important relation. So now we want to make a sandwich so that the middle part looks like the question. How can we do that? I want the middle part looks like sine theta over theta. Right now, the sine is on the left side, theta is in the middle, right? Tangent is on the right. What can we do? So then in the middle, we have sine over theta. Anyone? We can multiply or divide something. Any idea?
Multiply everything by 1 over theta.
Multiply everything by 1 over theta. then that will give you sine data over data.
Oh wait, we want the middle one, right?
Yeah, we want the middle one.
I'll
So
multiply everything by. Never mind. I don't know what's going
you're close. You're getting the idea, right?
on. Multiply by. You can't. I can't just multiply by sine, right?
You multiply by sine, then you get well, you get a sine in the middle. That's for sure. But then you will also have data next to it. So what we can do, right? I'm going to divide everything by sine first. Okay, both sides. So left side will become everything divided by sine. So left side will be, Jeffy, what do you think?
Just data.
Sine theta divided by sine theta.
Oh, just one.
Yeah, okay. Everything divided by sine theta. Middle one will become theta over sine theta, right? Right side, what do you get? Joan?
Tan theta over sine theta.
10 theta over sine theta. Okay, and then now the middle part is kind of like flip over, right? So what we can do is I can do reciprocal, right? Just like if you have 2 less than 3 less than 4, I can reciprocal the middle, but then at the same time, I need to reciprocal the other side and then the other side, right? Everything reciprocal. Now, is it still in the same order? Is it still from small to
No.
big? So
You
what?
gotta do. You gotta flip all the signs.
Yeah, we got to flip. Okay, but the middle one is still staying in the middle. That's the point, right? So I'm going to flip it, everything, and make it upside down. And then at the same time, flip, sorry, this one, flip the inequality. Right? Almost done. Now, the last thing I want to simplify a little bit is this one.
Wait, is sine over tan the cosine thingy? Didn't you teach us some weird like rules last year?
Yeah, some we have some identities, right?
Yeah, that's what it's called.
Yes. So tangent, I can write it as what over what?
Sine over cos.
Yes. Okay, so I can write it as sine theta over sine over cosine, right? And that will simplify into
Cos.
cosine. Very good. So there you go. We got our inequality. Okay. So we have sine theta over theta, right? In between cosine. And 1. I flip the order so it goes from small to big. And then we are going to take the limit, right? Because our question is to find the limit of sine theta over theta. But because that's too difficult, right, indeterminate, so we take the limit of the breadth, right? The lower one and the upper one, right? So we take the limit of cosine, right? And then we also take the limit of 1. What do they equal? Limit of 1 is 1, right? What's limit of cosine if I sub in 0?
Also one.
1.
So also 1, right? Also 1. So they all equal each other. They all equal to 1. Therefore, by square theorem, okay, we have limit of sine theta over theta equal to 1. So what this is saying, right? Because right now all you see is just symbol. It doesn't make much sense. So remember in a unit circle, that the picture that we drew. Okay, let's try to understand what it means. The question has limit angle approaching 0. So imagine the angle gets super small. Okay. So for example, right now, this is sine theta, right? We already showed that the opposite side should be sine theta. And then you have theta there, hypotenuse is 1. And then you have the green one, right? Okay, I would still use the blue. And then the arc one, which is theta here, right? Radius is 1. The formula for arc length, if you remember, arc length is theta times, anyone?
Radius squared.
Radius, just radius.
My bad. Radius.
Okay. So it will be theta times 1, right? Which is just theta. So the arc length is theta in a unit circle, right? And then sine theta is the opposite side. All right, so imagine if I make these two pictures, the angle gets smaller and smaller, super tiny.
Jason, I don't have enough space.
Oh, it's okay. We are not doing anything more.
Okay, thank you.
So just imagine here, right? If the angle gets super small, what can you tell me about the two red lines, the straight line and the arc line?
They're the same?
Yes, they become the same, right? When it's super tiny, when the angle gets close to 0, you cannot tell the difference between the two pictures. They are basically the same thing, and sine theta will be the same as theta when angle is small. And then that's why when you divide them, right, in the question, when you divide sine theta and theta, it will equal to 1. Okay, this is not a proof, but it's a way you can understand, right, why it works. Otherwise, just having a squeeze theorem doesn't make it like you can really imagine what's happening, right? But with this, right, it makes more sense. Right, so next one is the got to do with cosine, okay? So same idea, we are not using area. We are not using the squeeze theorem for this, okay? This one is easier to show. Same thing, right? Let's check if it's indeterminate. If I put 0 into the cosine, we get 1, right? So 1 minus 1 is 0 over 0, indeterminate. So how is this gonna be 0 then, right? So the way we're going to do this is to use Pythagorean identity, which in grade 12, we call it the square identity. And do you remember we drew a hexagon, right? To help you memorize the square identity. If you forgot, right, you can go ahead, take out your grade 12. So over here, let's copy the question down first. We are going to multiply top and bottom by 1 plus cosine. So kind of like the idea of conjugate, right? Except we don't have square root here. And once we done that, the denominator, I'm going to keep it apart. Okay, what's the numerator going to become?
Sine squared theta.
Let's step back a little bit.
Oh, my bad.
How do you know it's sine squared?
Because if you do difference of squares, it becomes 1 minus cos squared theta.
Yes, very good. And then from the square identity, that can become a sine squared. Okay. So feels like we are making question harder, right? And becomes more complicated now. Now the idea, the steps we are going to take from here is gonna help you in, it's gonna be similar things when we start to do question, okay? So you can see how it's being approached. So because we know that if I have sine theta over theta, the answer can be 1, right? It's not indeterminate. We already proved that. So we are going to take advantage of that, right? Gonna use that. So do you see any part here that has sine theta over theta? Any part of the question here that has sine theta?
Jason?
Yeah.
Can we split it into sine theta over theta times sine theta over 1 plus cos theta?
Yes, that's what we are going to do. We are going to do some splitting.
That's
So you have to be creative here, right? You got to move things around so then you can use your first rule, right? So I'm going to rewrite it. The top square, I can split it into sine times sine, right? And then one of the sine is going to pair with the theta in the denominator, and then the other sine will pair with the other denominator. So now because of the limit law, we can take the limit of each one, right? When multiplying, we can take limit of the first and then multiply by the limit of the second. So the limit of the sine theta over theta, right? Pretend you don't see this. That part is from number 1, right? So we know the answer for that will be 1. Now for the second part, if I sub in 0, the numerator will be 0. What about the denominator?
2.
Yeah, it will become a 2, right? It's no longer 0 over 0. So that's okay, right? So you get 0 at the end. So that's how you prove the second one. So these two are the most important one, and it's easy to mix up the two answers. So that's why I spend some time to explain this idea, right? The height and the arc length, they become close to each other so that you remember that sine theta over theta is 1. So the other one will be 0, okay? So don't mix up the two answers, right? Proof number 3, I'm not going to do that because you could also use the same sandwich, right? And then move them around, it will reach the same result, okay? So that's why for number 3, the answer will end up the same, okay? It works similar to sine theta over theta. All right, so that's all we need for the two. You can now call them identities, right? Because we are going to use those to do some questions, all right? Any question here?
No, Poppy.
Oh, you need a copy, huh? Okay.
No, I called you Pop. Never mind.
Oh,
I'm good. Thank you. Sorry.
good? Okay.
Yeah, thank you.
Yeah. Okay, so we move on. Let's look at question A. All right. So question A, we have sine 7 theta over 4 theta. Of course, what you can do, right, if you are allowed calculator, right, you can sub in a small, tiny 0.00 something, right, plug it in, top and bottom, right, and see what it equals, and then make a guess, right, what's the limit close to, right? But then sometimes you might get a decimal, it's hard to put into fractions. So here is what we need to do, right? So looks like is very similar to our rule number 1. Okay, how about let's just write down the 2 limits that we proved on the top, okay? So we don't need to flip back. So the first one we have is sine data over data equal 1, right? Second one, you can write on the top so you can refer to it equal to 0. Now for the second one, 1 minus cosine data over data. It doesn't have to be in that order. It could also be cosine data minus 1, right? Because
Wait,
yeah.
cosine theta minus 1?
Yeah, it will also approach 0 at the end.
Wait, but do we have to pull out the negative?
No, you don't need to, right? So
oh, because it's still going to be 0 either way.
Yeah.
Okay.
If you pull out a negative, 0 times negative is still going to be 0, right? Or if you do the conjugate, right? You can do it at time, it will end up the same. You can also prove it the same way. So sometimes they give it to you in cosine theta minus 1. It's the same. Okay, so in order to use the formula on the top or identity on the top, you must make sure the data are the same, right? Whatever that you see inside are the same. Then you can say it's 1. So right now, because 1 is 7 data, the bottom is 4 data, you cannot call it 1, okay? So you need to do something. Otherwise, it's too easy, right? So what we are going to do,
Jason?
yeah.
Wait, I have a question. So, like, about the last thing you said. So if it's like sine 100 theta over 100 theta, I can still say it's 1 because it's 100 theta on both, right?
Yes.
Okay, thank you.
Yeah. Okay, so whatever after, like whatever for the angle part has to be the same for it to work. Otherwise, they don't approach the same rate. Okay, they don't get small the same speed. Okay, so over here, just like the way we proved the second one, okay, we're going to do some splitting. Okay, so the 7 data, right, I'll put it like, just put it in the numerator. Oh. Okay, my program just crashed. Okay, give me 1 sec. I feel it's because the weather is too hot. my computer can handle it. Can you all see the screen now?
Yeah, it
Yep.
says loading documents.
Yep. All right, so good, it's still saved. So I'm gonna keep 7 data on the top, right? Sine 7 data, and then times it by, okay, times it by 1 over 4 data, right? So I'm just splitting it. So now what we want to do, right? We want to have the same angle on the top and bottom, right? So we need to have 7 data here and in the denominator. But then we cannot change the question, right? Because I just added something extra, right? So what should we do to make it balance out? I just added an extra 7 data, which was not in the question. So how can I balance that extra thing?
Do you make the other one 11 theta?
Will that cancel out the 7 data?
I don't know, Chief.
Well, if I put the 7 data at the bottom, what's the thing that we can do to cancel the bottom things?
You can put it at the top right in place of the 1.
Oh, that's so
Right,
genius.
very good. Okay, so So we have 7 data on the top, then that's gonna balance everything out, right? So once you have this, of course the data canceled out. Okay, remember, I do see some people, they do this. 7 data, they are so happy. You're left with sign. You cannot cancel the angles, all right? The inside the sign, you cannot do that. Okay, so therefore we are left with sine 7 data, right? 7 data and 7/4. Now this part is the part now you can use the identity, right? Use number 1 because now the angles are the same, right? They both approaching 0 at the same rate. When the angles are small, then they are equal to each other, right? So you just write equal to 1 times 7/4. So answer is 7/4. Any questions so far? Okay, so we're just trying to produce a look so that we can apply the identity. Okay, identity number 1, identity number 2. Okay, and sometimes you need to be creative, right? Move them around. Second one, I think you can do it because we've done something similar in the proof. Okay, so can you try question B? And please raise your hand when you finish. Or if you have question about A, right, let me know. Okay, so Jeffy, how did you do it? What's your first move?
I split sine squared theta over theta into sine theta over theta times sine theta over 1. Or just sine theta.
Yeah, looks good, right? So now you have this part, you can use the identity, right? The red circle one. So that part will equal to 1, right? And then
sine theta would just be 0.
yeah, so you sub in the 0 will be 0. So 1 times 0. This one is a pretty easy one. Okay, very straightforward, no trick. Okay, next part. This one is a bit tricky. Any question about B? Anyone? Nicole, Leon, how are you doing?
Oh, I just forgot to raise my hand.
Okay, Nicole, you doing good? Is your mic working? Because I can't hear you. Yes, sounds like your mic is not working. Okay, it's okay. Yeah. All right, so let's look at C, okay? C is different from A and B in what way? Take a look. What's the difference?
Wait, I have a question, Jason.
Yeah.
Is sine theta or sine 1 over theta the same thing as sine theta to the -1?
Yes.
Oh.
But then the -1 should be inside.
Or like
The-
sine -1 theta?
The exponent should be inside, right? Like that? Is that what you mean?
Oh. Okay, that's not what I was asking. Like that's not I asked wrong then. Yeah,
Oh.
that's what I was looking for.
Oh, okay.
Wait, so it's supposed to be like that, right?
Yeah, if you want to rewrite it, it will be theta to the -1
Oh, okay. Thank you.
exponent. Okay, so what other difference is there?
The
You're
theta.
multiplying theta again? Oh, sorry.
Oh,
Yeah. What?
theta is approaching infinity, not 0.
Yes, okay, that's the biggest difference, right? Because with theta approaching infinity, you cannot use the identity at all. No matter how hard you try to manipulate the question, right? You'll end up you'll end up seeing, oh, I cannot use it. Then you get stuck, right? So the first thing you need to take care of for this kind of question is do a replacement, substitution. So think about, okay, so we are going to introduce a variable, okay? So I'm going to let A to represent 1 over theta, right? To replace it. Now, if I take the data approaching infinity, what's going to happen to the value of A?
Super small.
Yes, right? Because the data is in the denominator, right? So 1 divided by super big, then you will have A approaching 0. So having data approaching infinity is the same as having A approaching 0 when you replace 1 over data with A. Okay, so this is the hint. I'm not gonna say more, okay? So I'll let you think about how we can use this to do this question. Okay, let you try. If you get an answer, please raise your hand.
Wait, sir?
Yes, sir.
What do we do with the extra theta in the front?
That's what you need to figure out.
Oh, sounds nice. Thank you.
I think I give you enough hint here, right? I still need to let you try it.
Okay,
right?
thank you.
Yep. Otherwise, I can keep going, writing, right? Then you just keep copying, then no fun.
Jason,
Yep, Jeffy.
when it says theta approaching to infinity equals A approaching to 0,
Mm-hmm.
does that mean we can use both of the limits? Or if we use both of them as limits, can we use both of them in the same question?
You can only use one.
Oh, okay.
Yeah.
Just
That's
check.
why we do the substitution, so we don't have to deal with infinity.
Oh, okay. Okay, I got it. Okay.
Yeah, because the identity we have, it doesn't have infinity, right? That's why the substitution.
Okay.
Don't be afraid to try, okay? So Joan, what's your answer?
I got 1.
Okay, I'll put that at the top column. Anyone else got it? Please raise your hand. So I know if I need to explain. Okay, Joan, how about you share with us what was your first line?
So for the first line, I did limit a approaching 0, and then I did 1 over a sine a.
1 over a sine a. How did you
Yeah.
get 1 over a?
I just replaced the 1 over theta like with a, because we knew that a equals 1 over theta is like just a approaching 0 is the same as theta approaching infinity. So I just replaced 1 over theta with a. And then for the theta that was on the left of the sign, I just did it so that if you plugged in 1 over theta in a, it would go back to theta. Does that make sense? I don't know.
Okay, okay. So let me show it on the screen, right? So
Yeah.
a is 1 over theta, right? So the inside the sign will be a, right? And then if a equal to 1 over theta, you could isolate theta, then theta will also be 1 over a, right? It's basically saying the same thing, right? And then after that, you just replace everything. Okay, how's everybody else doing? Right? If you get the answer, please raise your hand. I think it's by now it's pretty clear what's gonna happen. Any question? Leon, Jesse, Jeffy, Lex, Emily?
Oh, I didn't raise my hand. Oh, sorry. I didn't raise my hand.
Oh, okay. Right, because over here is pretty clear now, right? We need to do, just put them together, right? Sine A over A, so 1. Okay, anyone has question about this? So the unique thing about this question, right? If you do see this at school, right? And then, yeah, then you need to think about, okay, how can I make identity to be useful, right? Then you can do substitution. So this is the key step. Okay, next one. Okay, this one, I'm not going to do anything for you, right? So question D, you need, if you take a look, right, it has a sine double angle. So you might need to take a look at some identity. This is called double angle, right? Double angle identity. And this one has a cosine there. So maybe this one has to do with the second identity, right? Second identity has a cosine there, right? So I'd like you to try this by yourself. So we have 3 examples in front. I think you should be capable of doing this now. So raise your hand if you finish. If you don't have the grade 12 book, right, you can go online, Google the sine 2 theta, right, identity, and it should come up. or just simply type in double angle identity. Please raise your hand if you finished. Is there anyone here still have blank here or has no idea? I can help you. Okay, Leon, how are you doing?
Okay, so I use the rule, and then I have 2 sine beta minus 2 sine beta cosine beta
Okay,
over beta cosine beta.
all right. Did you do anything else after that?
I'm still trying to think from there.
Okay.
Jason, the denominator is theta times cosine theta, right?
That's right.
Okay.
Yep. Yeah, the first move is okay. Yeah, just apply the identity to sine cosine. Emily, how are you doing?
Hi.
Hi. So, are you okay? Like getting the answer?
Yeah, I'm fine.
Can you tell me what you did? Did you take the same first step?
Yes.
So what did you do after that?
Um, what I did was I took out, a 2 sine theta.
Okay, that's good. Take out 2 sine theta. What's left?
1 minus cos theta.
Over.
Same thing.
Okay. So by now, once you get here, that should pretty much tell you what you need to do, right?
Wait,
If you look at identity,
sir.
yeah, Jesse.
I definitely didn't do it this way. Was I supposed to?
I think this is the easy way. I would like to know how you did it though later. Okay.
Okay. Can I use the washroom really quickly? Thank you, sir.
You're welcome. Please raise your hand if you finished. So Jeffy, what's your final answer?
I have 0.
Okay. If you try to do substitution, if you sub in 0, you will get indeterminate again. Okay, so you have to use some identity to solve this kind of questions. Okay, so Joan, did you take the same path?
Yes.
Okay.
Or I was originally stuck on the first part, but adding the second part, I think I got it.
Okay, so what do you do after my second line?
So I still wrote out limit theta approaching 0.
Yep.
And I did like the splitting up part, so 2 sine theta over cosine theta.
Like
times,
like that?
yeah, like that. Times 1 minus cosine theta over theta.
Okay. All right, good. So that's going to look like number 2, right? The second part is going to look like number 2. Okay, Carrie, how are you doing? Any trouble?
I'm still working at the last step.
Okay. I think this one you could pair up differently too, right? You can also pair the sine theta with theta. That could also work, right? And then 1 minus cosine over cosine. So either way works. So Lex, what's your final answer?
0.
Yeah, you are Lex.
0.
0, okay. Leon,
I don't know. I'm kind of stuck.
do you have the same step as me?
Yeah, I think so.
You split up the same way?
Oh, I split up a little bit differently.
How did you split up?
I was thinking, I did sine beta over cosine beta, and then 2 times 1 minus cosine beta over beta.
Then that's the same, right? You mean like times 2 and then 1 minus
Oh
cosine.
yeah, I just moved the times to the other side, I think.
Yeah, you put the 2 on with the 1 minus cosine, right?
Yeah.
Yeah, so that's the same. And then are you stuck there?
Yeah, I don't know where to go.
Well, now is the time to apply the limit, right? Because now you see 1 minus cosine theta is over theta is the identity number 2, right?
Oh yeah.
So the limit of that will equal to what?
Just 1 over 0.
The limit of the green part, the green circle part.
Oh, would it be 0?
Yeah, it's the number 2, right? When you see that, you just say it equals to 0 because we've proved it, okay? So you just replace that with 0. So times it by 0, and then what about the second the first part, the red part.
Well, anything times 0 is just 0, right?
Okay. So, well, just to be sure, right? The first one, it will be 1 over what?
Give me a second.
If we're stopping 0,
Just be 0,
over
1.
yeah, okay? Because if you also get 0 over 0 in the first part, then we have trouble, okay? So you cannot just assume anything times 0 will be 0, okay? So you have to be careful. So this one, final answer is 0. Okay, I think this is enough to just to know what to do with identities, okay? Because the next one is gonna take much longer time. That's why the bigger space. So I'm gonna move on to derivative, okay? I think that's more important in this part. Okay, so for derivative, we have 6 rules, okay? So take a look.
Wait, Jason,
Yep,
can I
Jesse?
ask you if my way was legal, or do you want me? Do I ask you at break?
No, I want to know now. Yeah.
Oh, okay.
So,
So I did 2 sine theta over theta cos theta.
like this.
Yeah,
Okay.
and then subtract 2 sine theta cos theta over theta cos theta.
Okay. Yeah. So you split a fraction.
Yeah, and then I just and then on the left side it just becomes 2 because the cosine theta like cancels out. So then you use the rule and then it's -2. And then the other side, I did 2 sine theta over theta times 1 over cosine theta. Wait, sorry. Let me restate it.
Mm.
Okay, so the left side,
Mm-hmm.
it goes 2 sine theta over theta times 1 over cosine theta.
Okay. Hold on. Let me write it. 2 sine
Okay.
theta over theta times 1 over cosine theta.
Yeah, and then -2.
2. Just 2.
Yeah, just 2. Or because I already applied the law.
Okay. I'm gonna apply the law together at the same time.
Okay.
Right. So times it by 1. The cosine for the second part can cancel them. Right. So that gives you
Yeah.
a 1 there. Yeah.
And then
Sorry, it jumped.
oh, no worries.
Yeah, and then
And then it's 2 times 1
yeah,
-2 equals 0.
yeah.
I think that took way too long though compared to the way I'm supposed
Okay,
to do it.
it's pretty good, right? So that's the beauty of mathematics, right? You can look at the same problem. Everybody has different idea, just like calculus, right? With the same question of finding slope of tangent, they come up with 2 different definitions, right? But
Yeah.
reach the same answer. Okay,
Okay.
so that's really good. So
Thank you, sir.
yeah, so other people can look at. So it also encourage people to try, right? So there's no fixed way. Don't be afraid to take one wrong step, right? Maybe it take a bit longer, but you see more things. Okay, that's more philosophical now. Okay, so number 2, derivative. So sine prime equals to cosine. Okay, so this prime, right, means derivative. So it's saying that the slope of sine, right? Slope of tangent at any place for sine, it will become a cosine. And then number 2 is cosine prime is negative sine. You could box these two together, right? They kind of related to each other, right? And then tangent, cotangent, right? Tangent prime is secant square. Cotangent prime is negative cosecant square. So kind of like a pair, right? And then you have the secant prime is secant tangent. Cosecant prime is negative cosecant cotangent. So you will need to memorize these. It may sound like a lot of work, okay, but there's pattern here. So anybody can see pattern. How about pattern for the sign? Like positive, some of them positive, some of them negative. Is there a pattern for knowing which ones gets negative, which one stays positive?
The cosine, cotangent, and cosecant ones are always negative.
Okay, so you just need to remember all the code. Whenever you prime a code, they are bad. Okay, they get a negative, right? If you don't prime a code, they stay positive. Okay, and later I'll help you remember this one. Okay, these rules. But right now you can try. Right, we're going to quickly prove. Just prove maybe, I don't know, maybe prove 2, and then we can look at some questions. Or after proving, we take a break, and then we'll do the questions later, all right? So the way to prove this one, right? This is the function we want to show that when you prime, right? Prime will equal to cosine. Okay, become a new function. So we could use our definition, right? Because this one is the derivative at any x. So it has to be the third definition. So I will pick one of you, okay? Do you remember the third definition, what it looks like? Emily?
I think it's f of x plus h.
You forgot limit?
Yeah, sorry, the limit, h is equal to no. X is equal to 0.
Approaching 0, yes, yeah, good guess.
And then it goes
Mm-hmm.
f of x plus h,
Yeah,
minus,
yeah,
or was it minus? Okay, f of x
yeah.
all over h.
Yes, okay. It's minus, very good. Okay, minus because it's the slope, rise over run, right? You got to minus the 2y's and then minus the 2x. X plus h minus x give you h at the bottom. All right, so that's our definition, and we are going to apply this to our function. Okay, our function of the start, right, is the sine x. So please set it up. And I'm gonna pick one of you to tell me what to put. Okay, so Joan, can you tell me what to put on the top?
Wait, I'm still kind of confused.
About,
Just like, yeah, just how to set it up, I guess. I don't know. I'm like, I don't really know what's
but
going
you do remember this definition, right? Number 3?
Yeah. This one's the, yeah.
Okay, so the top, it says f of x plus h, right?
Right.
So it's asking you to input something into the function. What do we input?
The sine x plus h.
Yes, we put x plus h into sine,
Right.
right? So it'll be sine of x plus h, right? So if the function changes, then you put into a different function. The function we try to prove is a sine x. So you sub it into sine x. Okay, what about second part? Minus what?
Sine x.
Yes, okay, minus
Okay,
the
that makes sense.
original function. Remember?
Thank you.
Yeah. Okay, over h. Now, what can we do? Anyone? Anything from grade 12 that you learned that can help us?
Sine, cosine.
I was can remember that. Sine cosine, right?
Wait, is it
Told
for
you.
real?
Yep.
Oh, I was just saying random stuff.
You see the A, right? Two angles. This is called composite angle. Sine cosine, right? So this is sine cosine. Do you remember how to use it though? You know how to say
Oh,
it.
it's sine A cos B plus cos A sine B.
Yes.
Or I guess in this case, it's sine X cos H plus cos X sine H.
Okay, I'm gonna leave that to everybody. Okay, can you raise your hand once you fill in the sine cosine? Okay, I'm gonna leave that for you. Sine co. Anyone here doesn't know what that means, sine cosine? Please let me know. Raise your hand if you finish the numerator. Okay, Carrie, what do I write? Sine co and then what?
And then is it plus sine H cosine X?
Cosine, oh yeah, okay, you did the different order, right? Cosine X, sine H. So that's a sine cosine and then minus sine X. Any questions so far, everyone? And then the next part, what we are going to do is to move them a little bit, okay? The parts that have, we have something the same here, right? We have sine X, and the last term is also sine X. So I'm going to move the first term with the last term, okay? Put them side by side. And because they both have sine X, I'm going to factor it out. Okay, because I'm running out of space. I'm just, actually, no, I can write it. Okay, I'll just write it next to each other first. Right? And they both have sine X. So I can factor. All right, Jeffy, what do we have if I take out sine X?
You have cosine H minus 1.
Yep. Okay, and then outside we have a cosine X times sine H. And then they are all over H. Now for the all over H, I'm gonna skip a step and split the fraction. So I have the first part over H and also the second part over H. Any questions so far? How that happened? Let me know if you got lost. Okay, now what should we do next? We need to use something that we learned
Oh,
from last
we
class.
can separate the stuff.
What do you mean by that?
So it's limit h approaching to 0, and then the first part can be sine x.
Mm-hmm.
Or no. Wait. Oh yeah, sine x times cosine h minus 1 over h. And then we know cosine h minus 1 over h is 0, so it's just times 0.
Okay, so the way to show it properly, okay, I'm gonna rewrite it here.
Okay, sorry.
You have two parts, right? You have the sine x, and then Jesse said this is the identity, right? So we can take the limit, because the limit is taking h approaching 0, so h is the only variable, right? The only thing that's changing. So what you can do with the sine x, you treat it as a constant, right? Because h is approaching 0, x we don't care, right? So it's like a constant here. So sine x will just remain sine x, and then limit of the green part. Now same thing for the second limit, right? We can take the cosine x out and limit of the sine h over h. So another identity over there. Okay, so what's the first part? Joan, any question?
I'm just still writing stuff down.
Okay. Leon, any question about what you're writing?
No, I get it so far.
Okay, so what should we do next? We got our identity.
Are you asking anyone in general?
Anyone, yeah.
Oh, then you plug in the rule that we just learned on the last page.
So it will be sine x times
0
yeah plus
plus cosine x times 1.
this. So that's how you end up with a cosine x. Okay, so that's by definition, right? And then you found out that the slope of a sine, it will become a cosine graph. Okay, and how does that make sense? What we can do is to draw it out, right? Another way to visualize, right? Instead of looking at definition, let's look at sine graph. Sine graph start from 0, right? Go up, go down, go down, go up, right? 0, 1. Your arm exercise, right? This one is the sine x. And then we are going to draw the tangent graph. Sorry, the slope of tangent graph, right? The slope. Okay, so first we find the places that has 0, right? Slope that has 0. So this is the prime, okay? The prime graph. Let me use green. So the slope at pi over 2, this place is 0. So I'm going to put 0 there, right? All the slope is going to be the vertical value, right? When slope is 0, you put 0 there. And then another place that's 0 is over here, flat. That's another one, right? Everything to the left side of the 0, this tangent is positive, right? Going up. So it was, the steepest will be here. That one has a slope of 1 and then gets less steep. So it goes down. Okay, and then after it passes the flat point, it becomes a negative slope, right? And the lowest, this one has a slope in the middle is a -1. So it goes down to -1. And then similar thing will happen. It will look like that. Okay, and then this one is the cosine x, cosine graph. So that's another way to understand it. It's not proof, but it shows that it works. Okay?
Nice.
Yeah, so two ways to understand, right? The why these formulas works. So I'm gonna just throw you the way to memorize these 6 first, and then after the break, I will test you guys. Okay, because it's pretty easy to memorize them. And then the proving for number 2 is similar to number 1. Okay, all right. So let me show you how to memorize these ones. First, you draw the hexagon again. Okay, so please draw the hexagon. Okay, and then we are gonna place the trig the same way we did. Okay, so first we put a sine x at the top left corner, cosine x there, right? Tangent x there, and then their opposite we put the reciprocal, right? What's a sine reciprocal?
Cosecant.
Okay, cosine will be secant, right? And then tangent will be cotangent, right? And then after that, so right now up to here is what we used before. It was the you don't need to draw this part, okay? Don't draw this. This is review, right? That was for the square identity, right? We have sine squared plus cosine squared equal 1, right? Tangent squared plus 1 equals secant squared, right? Those ones. Now we are modifying this for the trig, for the derivative, okay? So what we are going to add in is we are going to add in the secant x on the left side, right? And then on the right side, we adding a cosecant x. And remember at the beginning, Jeffy said all the cot has negative, right? So look at the hexagon. Can you raise your hand if you finish drawing the hexagon?
Wait, can you re-explain why we have the red ones?
Yeah, I'll explain how that works. Okay, so draw it down first. There's no reason I put it there. Okay, it's just a trick to help you remember the 6 rules. Okay, so the only difference between this hexagon and the one you saw in grade 12 is the red. Okay, so we just added extra things. Please raise your hand if you finish drawing the hexagon. And then I'm gonna explain how that relates to the 6 rules. Yeah, okay, everyone's ready. So let's look at first rule, right? Can you guys turn on your mic? We'll say it together. Everyone, please. Okay, let's say it together. Sine prime equal cosine.
Sine prime
prime
equals
equals
cosine.
cosine.
Okay, so look at the picture, right? Sine prime equal cosine, right? Okay, and then cosine prime negative sine. Everyone?
Cosine prime
prime
negative
negative
sine.
sine.
Okay, because it's a cos, right? So it carries a negative, right? Cosine prime, it needs to be negative sine. So these two are paired. Okay, next one, let's say together, tangent prime secant squared.
Tangent.
Tangent
prime
prime
secant
secant
squared.
squared. Oh, there's 2
Look at
secants.
the picture. Look at the picture.
That's
Tangent prime,
genius.
right? You got secant and secant, so that's secant squared, right? Tangent prime secant squared. Okay, next one, I'm gonna look at the blue one. Okay, look at the middle blue one. Secant prime, everyone.
Secant prime.
Secant 10,
Secant
Ten.
Secant
right?
10. What
One
the
more
heck?
time. Secant prime, secant tangent.
Secant. What? Do you want us to say that one more time?
One more time. One more time.
Oh.
Secant
Okay.
prime.
Secant prime
Secant
secant
tangent.
tangent.
Secant
Okay,
10.
so look at the picture, right? Secant prime will be secant tangent.
That's genius.
Okay, now last one. Say it together. Cotangent prime negative cosecant square.
Cotangent prime negative cosecant squared.
Okay, so take a look. Cotangent prime. Remember, cot has a negative, right? So you got to just adding a negative. Cosecant, that's cosecant square. So cotangent prime is negative cosecant square. Last one, cosecant prime, negative cosecant cotangent.
Cosecant squared,
prime
negative
cosecant
cosecant cotangent.
Okay, very good. So therefore, same picture again, right? Cosecant is a cot. You need to add a negative sign. So you go backwards, right? You get cosecant cotangent. Don't forget the negative. That's all. Okay, so we have a break first. Right now it's 6:35, so I'll see you at 6:50. Okay.
Thank you, sir.
You guys need
Thank you.
Thank you.
for this one. Okay. Bye bye.
Jason, can you hear me?
Yes, I can hear you now. Welcome back.
Jason, I have to leave like early for class right now.